that x has to be a number greater than 0 because natural log does not exist. We remember the graph of natural log. Domain of natural log is anything to the right of 0. Good. So we know the critical numbers come from two sources, and we have to always check both. G prime of x equals 0, and G prime of x is undefined, but please remember, I've seen it in many of your work on this section, only where G of x is defined. So if you find here that x equals 7, as a critical number, it's undefined, G prime is undefined, x equals 7, you always have to go back and check if G of 7 exists. If G of 7 does not exist, there is no critical number. If G of 7 exists, then you will say yes. Okay? So please remember that. Okay. So we find G prime.
What are the cases where it cannot be undefined? Like,
which one? The derivative or the function?
I guess I should just.
Yeah. For example,
if there is a squared or like any even power in the denominator, that usually means there won't be undefined, right?
Correct. So if I have, for example, 1 over x squared plus 1, the function is defined everywhere, and the derivative will be defined everywhere. So nothing is undefined. But for example, if you have g of x, let's say the square of x, the domain of this function is 0 to infinity, but g prime of x is 1 over 2 the square of x, and the domain of this function is 0 to infinity. So there is a critical number at 0 where the function, the derivative is undefined, but the function is defined. But if they're both undefined, that's not a critical number. I'm not sure, did I answer your question, or is not? Is it?
Yeah, I'm good.
Perfect. So let's go back to G prime. It's a product, 2x times natural log x plus x squared times 1 over x. One more time. 2x times the second function plus x squared times this function prime. Yes, I will simplify. I don't have to state any restrictions because x has to be greater than 0 already. So then g prime of x equals 2x natural log x plus x. Of course, remember, factor simplify. I cannot stress enough. So here, of course, I will factor out x, and I have 2 natural log x plus 1. So now I have two possibilities to look at. G prime of x is 0, but I can never say that x is 0 because x is greater than 0. So the only option is 2 natural log x plus 1 is 0, or natural log x equals negative 1 over 2. And we have to solve this. Now g prime of x being undefined, none. Because this will be undefined at 0, but so is the function. So there is nothing here that the function, the derivative is undefined where the function is defined. Yeah, this will be undefined at 0, but so is the function. So none. So now I have to solve this. Anyone remembers how to solve natural log x? That's my page 5. Natural log x equals negative 1/2. How do we solve this?
Wouldn't it be x equals
Yes?
e to the negative 1/2?
Yes, e to negative 1/2 equals, excellent. So then from here I have that x equals 1 over the square root of e. Excellent. So this is a critical number. It comes from f prime being 0, g prime being 0. Any questions on this problem? Okay, let's see what else.
Could we do a graphing problem? I don't have anyone in mind, but just
Yes,
any.
yes. So I'm going to choose from page 327. We looked at rationals, we looked at we did some natural log. Should we look at a trig function?
How about the trig function?
Yep. Okay, let's do a trig function. They will take like forever, but we are up for the task. Okay. So let's look at 37, page 327. Y equals sine x plus the square root of 3 cosine x, they say. And the interval is negative 2 pi to 2 pi. Okay, so there are no asymptotes here. There is no problem, no limits whatsoever, because sine and cosine are defined everywhere. So we only need to determine the x and y intercepts right here, and then we'll move on to the first and then second. Okay, so when x is 0, this is 0, this is 1, so then the square root of 3. Because we are given a closed interval, I also have to determine the values here. Mandatory. Okay, and also I have to determine when y is 0. So we'll plug in the function, these two. We can do that right away. Negative 2 sine 2 pi, this is 0. And a negative cosine of negative 2 pi is cosine of 2 pi, which is 1. So this is still the square root of 3. And at 2 pi, this is still 0. This is still 1. And this is the square root of 3. Good. So when y is 0, sine x plus the square root of 3 cosine x equals 0. This is a typical situation in which we will divide both sides by cosine x. As long as cosine x is not 0. Well, it cannot be 0, because if cosine is 0, then sine is 1. And 1 plus this 1 will not be 0. So this is clear. In this equation, cosine will not be 0. Okay? I'm not eliminating a solution by dividing both sides by cosine. If cosine is 0, this is 0. But if cosine is 0, then sine is 1 or negative 1. But 1 or negative 1 will not equal 0. So that is okay. So when I divide both sides by cosine, sine over cosine is tangent x plus the square root of 3 equals 0. So then tangent x equals negative the square root of 3. So let's look at the unit circle. We know the tangent is positive here and here when both have the same sign, sine and cosine. But it's negative here and it's negative here. So this equation has two solutions. One with a terminal side in the second and one with a terminal side in the fourth. Now let's figure out which one. Is it pi over 6 or is it pi over 3? And how do I know? For pi over 6, I have sine over cosine, which will not give me the square root of 3. For pi over 3, I have the square root of 3 over 2 over 1/2, which will give me the square root of 3. So it's pi over 3. So the reference angle has to be pi over 3. So it's this angle, and it's this angle. So from negative 2 pi to positive 2, so negative 2 pi and then positive 2 pi. So we have 4 solutions actually. So we have this at negative pi over 3 plus pi. So 2 negative, because we have between negative 2 pi over 2 and 2 pi and negative and positive. So 2 negatives and 2 positives. So one will be pi minus pi over 3. The other one will be 2 pi minus pi over 3. So let me list all these. So tangent x equals negative the square root of 3. 2 negative solutions and 2 positive solutions. As I said, this is trig functions will require a lot of work, because even solving a trig equation is not a breeze, right? So let's start with the positive solutions. So this is here, pi minus pi over 3. One solution is pi minus pi over 3, and the other solution is 2 pi minus pi over 3. So this is 2 pi over 3, and this is 5 pi over 3. Now I have to figure out where to put them, because again, 2 pi over 3 is in the second quadrant. So I'll have to put in here negative pi. I don't want to put in anything that I don't really need. So between 0 and pi, so 3 pi over 2 and pi over 2, pi over 2, negative 3 pi over 2. So this is one. So this is one quadrant, the second, the third, the fourth. 1, 2, 3, 4 quadrants. Okay. So 2 pi over 3 is in the second quadrant, right here. 2 pi over 3, and this is 0. At 5 pi over 3 is here. 5 pi over 3, and it's 0. Okay, the other negative solutions now. Negative pi over 3. And the other solution would be negative pi over 3 minus pi. So negative pi over 3 minus pi. So negative 4 pi over 3. Okay, so negative pi over 3 is here. And negative 4 pi over 3. Negative 4 pi over 3. Right, it was this and this. Yes, still in the second quadrant. The second quadrant here. Negative 4 pi over 3. You can imagine when we get to this. Okay, so, well, we have to see one anyway, so that's okay. So now y prime. I have.
Will we have problems like this?
I knew I was gonna. The answer is yes, but not for test. I mean, it took me like 5 minutes to just find the solutions for the equation. How can I
I'm
put
still not
something?
exactly
How,
sure
how can
you
I
did that.
how can I put really? How can I put a problem like this on the test when it takes me, as I said, so minus the square root of 3 sine x. So now when I differentiate and set it equal to 0, again I have cosine x minus the square root of 3 sine x equals 0. Even before I selected the problem, I said, hold on to your seats. Okay, I divide again by cosine. So I have 1 minus the square root of 3 tangent x equals 0. So tangent x equals 1 over the square root of 3, or the square root of 3 over 3. And this will be x equals pi over 6. Okay. Okay, pi over 6. So from 0 to 2 pi, we have pi over 6. So we have this, and we have this. And also x pi plus pi over 6, 7 pi over 6. Just putting these two, and also these are just the positive solutions. I have to figure out the negative solutions, and I have to plug them in here. Goodness. So pi over 6 is 0, and 7 pi over 6. Where is 7 pi over 6 in the third quadrant? Where is my third quadrant? Here. 7 pi over 6. And then I need 2 more here, and then I have to study the sign. It will take another 20 minutes at least just to get through this and the second derivative. I can't, I can't, yeah.
So long it's not helpful for the test, then we don't have to go through it entirely.
We can just finish up one side, which just the positive side. So let me just do so since I started it, so I'm gonna just finish the positive side and ignore the negative side. So let's just work on this piece from 0 to 2 pi, one complete rotation. So that I can finish quickly. So from 0 to 2 pi, the derivative is this. Okay, so when I plug in 0, cosine is positive and this is 0. So this will be positive. Okay, when I plug into, what is here? When I plug in pi, this is negative and this is 0. And when I plug into pi, this is positive and this is 0. So that was, the negative side is more difficult. Okay, so now I have to find this, and I have to find this, and then I have to find the second derivative. Okay, so pi over 6 in the function 1/2, and the square root of 3 over 2. So 3 over 2 plus 1/2, this will be 2. 7 pi over 6, this will be negative 1/2 and negative the square root of 3 over 2. So this is negative 2. Okay, not too bad. The negative side it takes a little bit longer. Okay, so let's look at the second derivative. So the second derivative will be negative sine x, and then minus the square root of 3 cosine x. And the second derivative equals 0. What will I get? I will get that sine x equals negative the square root of 3. So this cosine x. So then tangent x equals negative the square root of 3. Again, the same thing. Okay, so and what did I get for that? The positive solutions, 2 pi over 3, 5 pi over 3. 2 pi over 3, 5 pi over 3. Okay, this is not too bad because I already had the solutions there. Okay, so for 0 here, 0, okay, negative. And for 7 pi over 6, so 1/2 plus 3. So this is negative 1/2 minus the square root of 3 and the square root of 3 over 2. Yeah, that's negative 2. Negative. No. What am I doing? Hold on. So this is positive. Okay, so it's positive. Sorry. Okay, so that's positive. And then for 2 pi, 0, yes, negative. Okay. I'm checking right now. So this is a maximum. So yes, that's correct. This is a minimum. Yes, that's correct. And this is a maximum. Yes, that's correct. So this one is an inflection point. This one is a max. This one is a min. This one is an inflection point. And that's it. So I can graph. Let me just quickly graph that and move on to the next topic.